Good morning, class. Let us start with the next topic for today. That's properties of addition and subtraction for integers. That how addition and subtraction follows the properties of integers, which are very important to analyze integers in deep. Are we clear with this? So we have 5 prominent properties for integers in case of addition and subtraction. The mainly 5 properties are: first property is closure property. Closure property. What is the pronunciation? It's closure. 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 Second important property is commutative property. Commutative property. I hope with the word itself you are getting what we have to do in this property. Commutative property. The third one is associative property. When we do the association, we use the associative property. Fourth is the identity property. We'll see what is the identity property. And last is the inverse property. So I'm writing the main title of the property, and then later on we'll be doing this properties in detail. So the name of the properties are closure property, commutative property, associative property, identity property, and inverse property. We'll see these 5 important properties which will help you in having great knowledge, deep knowledge about integers. Right? I hope you know. Just recap what are integers. Integers are the collection of whole numbers and the negatives of the natural numbers. Why we will not take the negative of 0? Because 0 itself is the neutral number. Are we clear? Every natural number is an integer, every whole number is an integer, but vice versa is not true. Are we clear? So let us start with the first property, closure property. Closure property also means that closed under. We'll see what is the meaning of closed under. I'll take you an example. For example, you are the student of OPS Vidya Mandir Sector 13 Karnal, right? Once you enter to the school, you are the part of the school. Yes or no? Every child has to follow the rules, the norms, and the regulation of the school. Everyone has to wear the same uniform. Everyone will be getting the same syllabus. Everyone will be having the same book for the same class. Everyone will be having the same concepts. Everything is same. Yes or no? So it means once you are closed under something, you are the part of that. You have to follow that. This is what closure property here means. Closure property states that if you add any number means any number of integers, if you add, or even I would say subtract, it would be better. I will take subtraction also here. If you add or subtract any number of integers, the result is always an integer. The result is always an integer. This is what closure property means. Same thing I told you. Once you are the part of any school, for example OPS Vidya Mandir, so once you enter, you are the part. You are closed under OPS Vidya Mandir. Whatever the rules and regulations are there, everyone is supposed to follow that. Everyone has to adhere to those rules. This is what closed under means. Closure property means you are closed under. So can I say integers are closed under addition? Integers are closed under subtraction. It means that whenever you will be adding any integers, you will be getting the result as integer. Whenever you will be subtracting any integer, the result will always be an integer. This is what closure property means. I hope it's clear to you. I'll be taking an example here, a very important example I can take. For example, 5 plus 2. 5 is an integer, 2 is integer, the result is 7. 7 is also an integer, hence verified. Next, 5 minus 3. Just see, 5 is an integer, minus 3 is an integer, So answer is true. 2 itself is an integer. Hence verified closure property. Hence integers are closed under addition and subtraction. Next important property is commutative property. Understand the meaning of communication. What do you mean by communication? For example, I'm on a call. If I'm going to say hello, the person on call would definitely reply with hello. And if I'm going to ask him how are you, definitely he would reply, I'm fine, thank you, you tell, etc. So what is happening here? If I'm talking to somebody, somebody is also talking to me. If A is talking to B, B is also talking to A definitely. Communication cannot be one way, it's two way always, or maybe three ways. It's three ways when more people are involved. When two people are involved, it's always two way. That is what commutative property means here. Commutative property states that if A plus B is there, it must be equal to B plus A. If A is added to B or B is added to A, then definitely A must be added to B. This is what communication. Right now what is happening? Communication is happening between A and B. Here also communication is happening between A and B. This is what commutative property means. Communication is happening right now. A is talking to B, B will also talk to A. This is what, for example, if I take 5 plus 3 or 3 plus 5, answer is 8. Any doubt with the commutative property? It's verified that if A plus B, it must be equal to B plus A, because addition always follow the commutative rule. Addition always follow the commutative. Next, let us take, this was the example of addition. Let us take the example of subtraction now. Let us see. Now, if I talk about A minus B equal to B minus A, let's see. Let us take an example. Whether subtraction follows the commutative property or no. Let's see. 5 minus 3 and 3 minus 5. This is what we are doing. 5 minus 3 is 2 and 3 minus plus minus minus, it is 2, 5 minus 3, but since 5 is greater, it will be minus 2. Are they equal? No, they are not equal. Hence, we will state that subtraction does not hold good for commutation. When we talk about commutative property does not hold good for subtraction, because subtraction does not follow. If A is talking to B, B is talking to A. Subtraction does not follow, but addition always follows. Are we clear with this? So, commutative property holds good for addition, but does not hold good for subtraction. Are we clear? Next important property, that's associative. What do you mean by association? Association, for example, if A is the friend of B and B is the friend of C, automatically A and C will become the friends. Yes or no? If A is the friend of B and B is the friend of C, then A will definitely become the friend of C. This is what association, when you are associating together. If you are the part of team B, definitely, and any member of team B is part of yours, definitely you become the part of together. That is what associative property means. So let us see what is it. Associative property states that if A is given and B and C are associated, then it must be equal to A plus B associated together plus C, or is also equal to A plus C associated together resulting B. This is what associative property means. Why? Because here association is happening between B and C, A and B, A and C, and automatically it is transferring to another person. This is what association here means. Are we clear with the association part? That what do you mean by association here? Association is happening, you can see clearly. Clear? Now let us take an example. For example, A is equal to 2, B is equal to 3, and C is equal to 4. Let us take an example. 2, 3 plus 4, 2 plus 7, that is equal to 9. Now 2 plus 3 plus 4, that's 5 plus 4, that's again equal to 9. 2 plus 4 plus 3, 6 plus 3, that is equal to 9. Hence 9 is equal to 9 is equal to 9. Hence associative property holds good for addition. It holds good for addition. Your homework is you have to check associative property for subtraction, and I'm sure the result will not be good for you because subtraction does not hold good for associative property. Associative subtraction does not follow associative property. Are we clear? You can see because A plus B again same thing as happening, communication. If subtraction is not following commutative property, definitely it will not follow the associative property. Are we clear? So that's your homework. You will try one of the parts of that. Next important thing is your identity. Your identity. If you want to see your real identity, where you will see yourself? In the mirror. Mirror shows you the real identity of you, right? If you see yourself in a mirror, you'll definitely see what kind of person you are. What is your feature? What are your characteristics? You can see clearly because mirror doesn't lie to you. Same thing happens here. In the case of integers, we have something called identity. That what shall I add in an integer so that I get a same integer back? What shall I add to an integer so that I get a same integer back? And the answer is very clear to it. Answer is 0. Because if any number is added to 0, the result is always same. So what is 0 called? 0 is called additive identity. So what is the additive identity of any integer? Answer is 0. Answer is 0. 0 is the answer. Additive. We don't have subtractive identity. No. We have always additive identity because you know subtraction is not following maximum rules. Addition is following closure property also, addition is following commutative property also, addition is following associative property also. That is why we talk about addition more. That's why we talk about addition more, because it follows maximum number of properties. But if we talk about subtraction, though subtraction follows closure property, but it does not hold good for the commutative and associative. Hence we don't talk about the subtractive identity. We don't have something called subtractive identity. Clear? Next is inverse. What do you mean by inverse? Reciprocal, exactly opposite to something. Inverse. For example, if I talk about what is the inverse of 2? What is your answer? 1 by 2. So clearly, if I talk about inverse, inverse means reciprocal. Reciprocal of 2 will be 1 by 2. Numerator will become denominator, denominator will become numerator. This is what happens. So, what do you mean by inverse? What do you mean by inverse here? So, in inverse, again we'll be talking about additive inverse. We'll be talking about additive inverse. Now, additive inverse itself is stating means sign plus minus. Additive here means plus minus. So, in case of additive inverse, what we do? We change the sign. We change the sign. Okay. For example, your plus will become minus and your minus will become plus. This is a simple fundamental. This is simple rule for the additive inverse. For example, if I give you example, what is the additive inverse of minus 5? The answer is 5. So AI means additive inverse of any number is just change the sign of that number. Plus will become negative, negative will become positive. Are we clear? Plus will become minus, minus will become plus. Any doubt with this? Anyone is having any doubt with this? So these are the 5 important properties of integers that you have to follow. Any doubt anyone is having till now? Next, one of the important topics. Again, we'll be talking about absolute value of an integer. What do you mean by absolute? Means the exact value. Absolutely correct. Means exactly correct. Absolute value. How we represent? In these 2 vertical bars we represent absolute. For example, I am writing minus 8. What is the absolute value of minus a? Absolute value of minus a is a. It means every negative integers will be converted into positive. That is what absolute value of an integer. Why we are talking about absolute value? Because we can talk about positives. It's easy to talk about positive. Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, 7, 8. We can do. But once we talk about minus integers, negative integers, we cannot calculate them easily. I cannot represent. I have to make a number line, then I have to represent. But that's to a different way. But if in the real world I have to show somebody how negative integers are there, that's a difficult task. That's why we talk about the absolute value. Because any negative integer converting to positive integer, we can put the absolute value of that integer. So are we clear? So what is the absolute value of minus 6? Answer is 6. What is the absolute value of 7? Answer is 7 only. Now don't think if positive is there, we have to convert. We are not talking about additive inverse. We are talking about absolute value. So in case of absolute value, do remember only negatives will be changed to positive. Positive will remain only positive. And this is how we represent absolute value. Absolute value. Are we clear? That's very, very important. You should know absolute value. And why we talk about absolute value? Because positives are easy to represent. Count. We can count positive values, but we cannot count negative values. That's why we talk about the absolute value. Are we clear with this? So let's move on to exercise 1.2, which is completely based on this. So I'll request you all to open your books for exercise 1.2. Exercise 1.2. First question. Write down a pair of integers, when given by pair means 2, whose sum is minus 7. Okay. First condition, sum is minus 7. It's very easy. We have to write the integers, two pair of integers whose sum is minus 7. That's very easy. I can say minus 5 plus of minus 2. That is again minus 5 plus minus minus. Minus minus plus, that is 7. These both are having minus 7. So one pair is minus 5 minus 2. Even if I talk about minus 9 plus of 2, what is the answer? Plus minus minus, 9 minus 2, 7. But here since 9 is bigger and negative sign is a minus, so one more pair is minus 9 into 2. This way you can have any number of pairs for this, whose sum must, not I'm talking about subtraction, I'm talking about sum. That is why I've written plus, that is why I've written plus. Are we clear? Next, D part. Difference is minus 10. Very easy. Difference is minus 10. Can I write? Any doubt? Why I'm talking about difference? Because minus sign has to be there. Minus, 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 plus, plus, minus, minus 20 minus 10 is 10. Since 20 is bigger, minus 10. So the pairs are, one of the pair is minus 20 minus 10. Similarly, you can have another pair. Third part, sum is 0, very easy. Sum is 0, very easy. Take one positive integer, take one negative integer, add them. 7 plus of minus 7. 7 plus minus minus, 7 minus 7, 0. So 7 minus 7, 11 minus 11, all are examples, etc. Pair of integers whose sum is 0. Are we clear? Very easy. Next, question number 2. Write a pair of negative integers whose difference gives 8. Question number 2. Write a pair of negative integers. Conditions there, you have to write the pair of negative integers whose difference gives 8. Whose difference gives you 8. So negative whose difference, pair whose difference. So can I write better? I can make it as, we have to write plus 8. Simple. And both should be negative integers. That's very, very important. So can we have minus 6 minus of minus 14? I think this is one of the best examples. minus 6 plus minus 14. What is the answer? 8. So hence one of the pair is minus 6 minus 14. Can we have another examples? Yes. Minus 4 minus of minus 12 minus 4 plus 12, that is again 8. Are we clear? Second part, write a negative integer and positive integer whose sum is minus 5. One negative and one positive whose sum is minus 5. Very easy. I can write minus 50 plus 10. One negative integer, one positive integer whose sum is minus 5. Plus minus, minus 15 minus 10, 5. Since minus 50 is greater, minus sign. Are we clear? Can we do? Or minus 8 plus 3, that's again minus 5. Yeah. Option third part, write a negative integer and positive integer whose sum is minus 3. That's your homework. Third part is your homework. You will be trying this. Next, in a quiz, a team A scored, okay, question number 3, again a quiz question, exercise 1.1 also we were having question number 3 as a quiz question. Next, question number 3, in a quiz, team A, we have team A scored minus 40, 10, 0, team B scored 10, 0, minus 40. In 3 successive rounds. I told you successive rounds means 1 by 1. Which team scored more? Can we say that we can add integers in any order? Let's see. We have to add simply. So the final score is equal to minus 40 plus 10 plus 0 plus minus minus. So 40 minus 10, that is 30. Since minus 40 is written, minus 30. Here also the final score, that is 10 plus 0 plus of minus 40. So 10 plus 0 minus 40. It is also 10 minus 40. Again plus minus 0. That is minus 30. Both are getting same score. Minus 30 minus 30. He is asking which team scored more. Both teams scored the same score. That's minus 30 minus 30. And next question is, can we say that we can add integers in any order? Yes, we can add. Why? Because addition follows which property? Commutative property. Do you remember? A plus B is equal to B plus C. That is why. So we can add them in any order. This is what commutative property states. If you add any integers, you can add them in any order. If you write 1 plus 3 or 3 plus 1, the answer is same. Are we clear with this? Next question. Question number 4. Filling the blanks to make the following statements true. Question number 4. Filling the blanks to make the following statements true. First part I am going to do for you. Minus 5 plus of minus 8 is equal to minus 8 plus dash. Very easy. Definitely, to make it true, this is 1, this is 1, this is one integer, this is one integer, plus sign is there. Definitely they will be following commutative property. It should be minus 5. And write down in the bracket which property you followed. That's commutative property. You have to write the property, though it is not given, but you will mention the property. You followed the commutative property. Similarly, B part, second, minus 53 plus dash is equal to minus 53. Which one? What number I shall add? That's very good. That's 0. Which property? Additive identity. Are we clear with this? Rest of the parts you can do. That's your homework. You have to try. I'll be doing the fourth one for you. 13 plus of minus 12 plus dash is equal to 13, bracket starts, minus 12 plus of minus 7. Very easy, you can see. Here 13 and minus 12 is associated. Here minus 12 and 7 is associated and 30 is in unknown. So what is this? Definitely this is minus 7. And which property? That's associative property you have used. Association. Are we clear? Easy to understand. So this is how you have to do. Question number 5. If A is equal to 3, B is equal to 5 and C is equal to -4, verify. I'll be doing A, you can do. In A part, since A plus B is equal to B plus A, so you'll be using only A and B. I'll be doing the second part. Verify. Second part, A plus B plus C is equal to A plus B plus C. See how to do such questions. First of all, properly you'll be writing LHS, here RHS in case of verification. LHS is A, B plus C, and RHS is A plus B plus C. Now next line you'll be writing on substituting. I told you in the previous class also, previous exercise, on substituting the value of A, B and C. Now A is equal to 3, 3 plus 5. It's very important, guys. C is -4, so you'll be keeping minus terms in the bracket to avoid any confusion. Similarly, 3 plus 5 plus of -4. Solve it. 3, we'll be solving the bracket first as per the board mark. 5 plus minus 3, 5 minus 4, that's 1, 3 plus 1 is 4. That's 2 plus of -4, that's 2 minus 4, that's equal to -2. Are they equal? No, we are not. We cannot verify them. Since LHS is not equal to RHS, hence not verified. Can you tell me why this happened? Because one of the number is negative, and negative integers, subtraction, does not hold good for association. This is what is happening. Are we clear? Rest of the parts you can try. So till now we have covered very important topics of integers, and we have completed 2 important operations of integers, addition and subtraction. In the next class we'll be doing the next operation, that is multiplication. Till then, have a blissful and wonderful day.